All right, so we're going to do a little review of complete the square, or CTS is how I usually write it on the board. So completing the square is kind of just factoring, but where the sides of the box have to be the same. So if you think back to when we talked about factoring, what we said is that, like if I wanted to solve this, I could have like x plus 2 and x minus 5 on the sides of the box. Completing the square is the same idea. The only difference is that the sides of the box have to be the same. So if this is x plus 2 up here, that had to be x plus 2 down there. So they're very similar in that idea. How we set it up is basically the same way. So the x squared still goes in the upper left, the 36 still goes in the bottom right, but the rule is that in order for this to work out, these two boxes need to be the same size, meaning this 12x needs to be broken into equal parts. In this case, 6x and 6x. That would mean that the outsides of our box would be x plus 6 and x plus 6. In other words, this could be rewritten, this whole phrase could be rewritten as x plus 6 times x plus 6, if I wanted to write it as the factored form. Or, if I wanted to be even more succinct, I can write it as x plus 6 squared. This is the step we're really looking to get to, where I can write it as one side of the box squared. That's the whole purpose of this completing the square setup. Now, it's not always going to be written out this nicely, where I have it already set up so that it perfectly works out where half of this number squared works out to be exactly that number. So that's not usually the case. Normally, what we get is a problem that looks like this. So what we said to do in class was the very first piece you want to do is move this c value that I'm given to the other side, because chances are it doesn't work for what we want to do. So we're going to move that over, and we're left with negative 91 over there. Now I'm going to pretend that negative 91 isn't there for a minute. I'm going to ignore it. And I'm going to put this stuff, this p squared and the negative 20p, in our box. So p squared, and like we said, we want this to be broken up evenly into the other two boxes. So negative 10 and negative 10. Now, based on what's there, I don't have a piece down here yet, but I can figure out what it needs to be by figuring out what the sides of the boxes need to be in order to make the stuff I already do have. So I know that based on our factoring idea, this should be p, this should be negative 10, this should be p, and this should be negative 10. So this works out nicely because the sides of the boxes are the same, but by doing that, I automatically end up with an extra 100 down here that I did not originally have in my problem. This is what we're going to end up adding into the problem here. So it's going to become p squared minus the 20p. But then we're going to add in 100. So that the left side of our problem is like what we had before, where it worked out perfectly to make a perfect square. But if I do that on the left side, algebraically, we know we have to add the same amount to the right side. But now I can rewrite this left side as the sides of the box, which is p minus 10 times p minus 10, or p times p minus 10, or p minus 10 squared. And then this side I can simplify. Negative 91 plus that 100 comes out to 9. Now I'm in a setup kind of like what I had before, but this is something we know how to solve by square roots. So from here, I know I can square root both sides. So I'm taking, in case you didn't miss that step there, taking the square root of both sides. The square root and squared cancel. Square root of 9 is just 3. And my two solutions are 10 plus or minus 3, which would be 10 plus 3, 13, 10 minus 3, 7. Now, some of you asked me in class, well, what about if I don't want to use the box? I just want to do it all algebraically. Well, it's kind of the same idea. First things first, we move our c value to the other side. And then, in order to figure out what that c value is that we're going to add on, what you want to do is kind of think about the box. So like here we said we want to split this 20p up evenly into two pieces. In other words, we split it in half. That's what I'm going to do here, is I'm going to take, in this case conveniently, it's also negative 20. So half of that is negative 10. So I'm going to add on negative 10 squared to both sides, because that's the piece we're adding in. And then what we said was that it was the sides of the box is how we rewrote it, which was our letter, and then that half piece showed up here. So that negative 10 that was inside the box also showed up outside. Same thing here. So I can rewrite this as x minus 10 squared. And over here, we would end up with 196 because this would be 100. And again, we're set up to solve. So square root both sides, I'm left with x minus 10. I don't really need that parenthesis. Square root of the other side would be plus or minus 14. So my two solutions end up being 10 plus or minus 14, which would be 10 plus 14 is 24. 10 minus 14 would be negative 4. Now, we're going to set that up one more time, just to be clear about what's going on there, in case you're struggling yet. So, algebraically, we start off x squared minus 16x minus 15 equals 7. Why not? So, first things first, you move your c value to the other side. So in this case, I'm just adding 15, in case you're stuck there. Then, to figure out what I'm going to be adding on to both sides, I take half of my b value, so in this case, half of negative 16, which is negative 8, and I'm going to square it. So negative 8 squared, negative 8 squared. To rewrite, whatever that half piece was is what's going to go right here. So that's 64. It should be 86 over here, I believe. Now I'm set up to square root. And add the 8 on. So I hope that helps with completing the square. Again, it's factoring, but where the sides of the boxes have to be the same. And sometimes you may have to add in a value in order to make things work out the way you need them to. It's important to remember that whatever I'm adding in on both sides. And mainly, our goal is to get to a point where we can use solving by square roots. So something squared equals a number that we can square root and solve from. So I hope that helps.